Hello and welcome to the SAS video tutorials. Now we will be talking about formatting data values. First, we would be using the SAS formats. So our objectives would be to describe the SAS formats, and then we will apply those SAS formats with the format state. The scenario that we have is that we need to enhance the appearance of our report, not only the variable names. We have seen that the numeric values such as salary, birth date, hire date can be difficult to read in reports. Adding commas to separate them and displaying SAS dates as calendar dates would improve the report. SAS offers format which we can apply with a format statement to change the way a value is displayed in the output. SAS format. What is it? SAS format can be used in a proc step to change how the values are displayed in a report. So we use format statement in proc step to get these values applied or these formats applied to our reports. Format statement. The format statement associates a format with a variable. The syntax is format, variables format. Variables are the name of any variable that we want to give, and if we want to apply any format, then that is a mandatory syntax. According to the program here in the format statement, we are using a $8 period format with salary, MMDDYY10 period format with hire underscore date. Let's open this program and submit, and let's see what are the output that we get. First, we will submit the program where we will not apply the format, and then we will submit the program where we will be applying the format and we will be seeing the difference. Let's go ahead and submit this program and check what does the output look like. Here if you see the salary, so it just numbers, it does not separate itself with comma, or it does not say which currency it belongs to. And then hire date, you see these are numbers. I don't know what date it is, like 12,205 or by any normal person. Let's go ahead and submit the other code. So I'll go ahead and submit this code as of now, and let's check where I have applied the format. See, now the salary comes in dollar. It appears in with a dollar sign, and it has comma after every 3 numeric digits. Now it is easy to read and you can understand it better. Date, now you know it's 06/01/1993. 12,503 was not understood by me, neither by anyone. That is how SAS saves it in dataset so that it can perform the calculations easily. But when we want to display, we have to use formats to display it in a way so that we can understand it. The format was applied to all the values of the variable. Now let's go back to our presentation. So what is a format? We have seen how it differs, how it shows us the result, but what is a format? A format is an instruction to write data values. A format changes the appearance of a variable's value in a report. The values stored in the dataset are not changed. So a format is an instruction that tells SAS how to display a report. A numeric value can be displayed with commas and match with a dollar sign. A format is an instruction that tells SAS how to display the values in the report. A numeric value can be displayed with commas and may be with a dollar sign. A SAS date can be displayed in one of the many calendar styles. Formats do not change the stored value. SAS formats. SAS formats have the following form. Dollar, which is optional. Format, that's the name of the format that we are using and what format we are using. W is the width. And then a period, which is mandatory in formats whenever we are talking about formats, and then D, which is a decimal place, which is again optional. SAS formats. Selected SAS formats are, like if we talk about $W period, then it writes standard character data. W.D writes standard numeric data. Comma W period D, it writes numeric values with a comma that separates every 3 digits and a period that separates the decimal fraction. $W period D writes numeric values with a leading dollar sign, a comma that separate every 3 digit and a period that separates the decimal fraction. Comma XW period D writes numeric values with a period that separate every 3 digits and a comma that separates the decimal fraction. Euro XW.D writes numeric value with a leading euro symbol, a period that separates every 3 digits, and a comma that separates the decimal fraction. So the values for the formats without X here are in the European format. SAS format examples. $4 period. Programming. Stored value. We know that it's a character value and length is 4. So it just picks up the 4 characters from the beginning. Then we have 12 period. So it gives the value as 27135. Then we need to have decimal, then 12 period 2. So it will take 2 characters after decimal, and this 12 will include decimal as well. Then comma 12 period 2 is the same, but it will include the symbol comma. $12.2 will include comma as well as a dollar sign. Comma x 12 period 2 will include a decimal point that would be separating the numeric digits after every 3 characters, after every 3 digits, and the decimal place would be separated with a comma. Euro x 12 period 2. So it will have a euro sign front of the value, and then the numeric digits would be separated after every 3 digits with a decimal, and the decimal will be separated by a comma symbol. SAS format example. If the format width is not large enough to accommodate a numeric value, the displayed value is automatically adjusted to fit the width. So here we have just changed the width in the format column, and the stored value remains the same through all the examples that we have taken, and how it affects a displayed value that is given based on the format. So we have used $12 period 2. There it was able to accommodate all the digits, except as we have specified that we need only 2 decimal places, so it has only 2 decimal places there. Then $9 period 2, you see the total number of characters including the dollar should be 9. So if we check our digit, which is more than 9, so we have according to the priority, comma is the least important character that needs to be there in the displayed value. So they keep the dollar sign and remove the comma because we have to have the complete length as 9. When we use $8 period 2, the stored value remains the same, but the displayed value does not have a dollar sign because the total character length or total length of this number displayed value is 8. Then $5 period 2. So it must have only 5 digits as a displayed value. So the decimal's importance is removed. Then $4 period 2. As the number itself is larger than the specified width, so it converts the number into an exponential format. It's an important information. The ZW.D or ZW period D format writes standard numeric data with leading zeros. It is similar to the W.D format except that ZW period D pads right aligned output with zeros instead of blank. So kind of example that I can take is that, like, if I have defined a character length, so if I have defined the length of the format to be 8 and my number of digit is 4, so it will have 4 zeros before it, that is the leading zeros, and then I will have my number. So as the defined length is like Z8 dot, so if that is the case, then this would be the out. SAS date format examples. SAS date format displays SAS date value in standard date forms. MMDDYY, that is month, date, year. So this will always represent a numeric pattern of displaying date, that is 01 slash, which is a forward slash 01 forward slash 1960, because the stored value is 0 and SAS base value is 1st January 1960. And then when we have given the width as 8 period, so you see 19 is missing, so that is the least important value that can be taken off when we give the width as 8. And when the width is 6, all the forward slash does not hold much importance because the length has to be, the complete date value has to accommodate itself within the given width. Similarly, the next example where the date comes first, then month, and then year, SAS date format examples. So there are ways, those were the kind of a numeric representation of the dates. Now if we have to write the dates in the current format like December, January, the word English word format, then we have the other ways to apply these formats. So for that, if we talk about date 7 period and the stored value is -1, that means it's 1 day prior to the base date, that would be 31st December 59. So it represents the value as 31st, that is the date value, and the first 3 characters of any month as the name of the month, and then 2 characters of the year. Similarly, with date 9 period with the stored value -1, we have 31st DEC 1959. So year value gets added here. The complete year 4-digit value is displayed here. Word date. So that means we want the date or the name of the month to be appearing in English. That's why we have January 1st, 1960. So that is the way that it gets displayed when we use word date. Week date will have the week day name along with it. MONYY. So MON seems to be very much English in nature. So we have Jan 1960 where the date is not displayed. Only the month and the year is displayed. And if we do MONYY 5 dot, so Jan 60 would be printed. Year 4 period. If the stored value is 0, then it just displays the year value, that is 1960. We will see examples like how we apply these formats. So here it is the same program that we used earlier with label statement, but we have added more labels here and we have used a format statement as well. Now we are going to apply the $10 period 0 format here. So that means we don't want any decimal values to be printed after that. And for birth date and hire date, we are using MONYY7 period format. So which will display the month name with 3-letter abbreviation and the 2 digits of the year and the 4 digits of the year. Let's go ahead and execute this program. So now if we see our previous report, the date value was in MMDDYY. But as of now, the date value has changed because we have applied a different format, and annual salary, it remains same. Formatting data values, we will continue with user-defined formats. Our objectives would be to create user-defined formats using the format procedure. Apply user-defined formats using a format statement in a report, and we will use formats to recode data values, and we will use format to collapse or aggregate data. Business scenario that we have here is to display the country names instead of country codes in a report. Let's go ahead and open this program and run. So here what we have done, we are using a proc format, that is a procedure by which we create format. Then we give the syntax value as the value, which is a required syntax. This defines what value we are going to use to define what kind of format. Dollar is optional. If the format is character format, then we use dollar symbol, otherwise we don't use. Then we have country FMT, that is the name of our format, and this is the value in the SAS data set, and we want Australia, the complete name, to be masking it in the data values, so this will act as a label. Similarly it goes for US, and for other is not any word, it is a keyword here because this is not enclosed in quotes. If we close in quotes, it will look for the particular word other in the variable. So whenever it finds any value apart from AU or US in caps, it will give the value as miscoded. Let's create this format. Format procedure does not give the print. Format procedure does not produce any report. So we might have to look for the log to check if the format has been created. So here in the note it says format $CTRYFMT has been output. That means the format has been created and we can apply this format as of now. We will go back to our program and then we will apply that user defined format along with the SAS defined formats in our program. Let's submit this part of the program and check the values. Observe that the country value from AU, it has converted to Australia, and to United States from US. So we can create our own formats and apply them to a report. Let's check the log. So it will just give you the number of observations it has processed and read. Let's go to our presentation. As we have already processed this program. So user defined formats part 1. So here, as I have already explained, $country FMT, that is the name of the format, and I have already explained the syntax goes proc format, which is mandatory, value is again mandatory, and then the format name, that could be any name that we would want to give, and then the range. So range, what range defines here is not exactly always a range. There was a single value, so do not get confused with that. We will talk about this later in this chapter. Then we have label, whatever label we want to put, or the whatever value we want to display whenever it finds any value within that range. User defined formats part 2. Use format statement in proc print step to apply the format to a specific variable. So in the proc print, what we did is that We applied the user-defined formats with the country variable where we have used $CTRYFMT. That was the format that we created, and then we got to the output. And this was our output that we have already seen while we were doing the demonstration. The value statement. A format name can be up to 32 characters in length. For character formats, it must begin with a $sign followed by a letter or underscore. For numeric formats, must begin with a letter or underscore. It cannot end in a number, because if it ends in a number, when we are going to apply that format, it will take that number as the width of that format. We cannot give the name of a SAS format to a user-defined formats. We cannot include a period in the value statement, because when we want to call that format, we will not be able to give two periods when we want to call this format. Each range can be a single value, a range of values, a list of values, and the labels, which can be up to 32,767 characters in length, and those must be enclosed in quotation mark. Defining a character format name, discrete character values, and then the keyword, that is other, and the labels that are miscoded United States and Australia. The other keyword includes all values that do not match any other values or the range. Applying a format, user-defined and SAS formats can be applied in a single format statement that we have already seen. A period, for example, at the end of the $CTRYFMT format is required when user-defined formats are used in format statement. Scenario: an Orient Star manager wants a report showing employee salary collapsed into three user-defined groups or tiers. So we specify a range of values. Use proc format to specify the salary range for each tier. So here the example is, there's the manager, we apply a proc format, and this should be the way the values are displayed. Salary: if someone's salary ranges from 0 to 49,999, he should be put into the tier 1 group, and if someone's salary is between 50,000 to 99,999, he should be put to tier 2 group, and someone's salary above 100,000 reaching to 250,000 should put to tier 3. Defining a numeric format. Proc format, value, tiers. Tiers is the name of the format. We did not use dollar because it's a numeric format. And then we have defined a numeric range. 0 to 49,999 is the range. Then we give tier 1, and respectively we complete the program. Let's go ahead and say it's proc format. So this is the tier format that we are creating. So we will just execute this format and we will check the log if the format was created. Yes, format tiers has been output. That means this format has been created. And then here we have actually created a data set. So we will not talk about it here. In later courses, we have this chapter, this section covered. So there we will be talking about it. Let's go ahead and create this data set and check the log because we are not printing it yet. Okay. A dataset work.salaries has 6 observations and 3 variables. So a dataset has been created. If you want to check, we can go to Explorer and we will go to work library as it's a temporary dataset that has been created, and salaries, right? We will double click salaries and we will see our data, what is present. So name, salary, and the original salary. So salary and original salary have the same value. Because we are going to label the salary variable, that's why we have created additional column or the variable that is original underscore salary. So we will close this view and we will go back to our programming interface. And here now we are going to do a proc print where we are going to apply the same tier format. Let's go ahead and execute this program. So here if you see, everyone has got a group like Abhi, Mike, Josh, they got to tier 2 group, Joe got in tier 1, and Ursula went to tier 3. But Lou did not go anywhere. Why has this happened? So if we check their original salary, so Lou has 49,999 period 99. That means he does not fall into the range that actually he is supposed to fall in. because the range we have decided is from 0 to 49,999, right? So we will see how to overcome this kind of situation. Defining a continuous range. So this is the way we are going to handle this kind of exception. So less than symbol exclude the endpoints from a range, allowing a continuous range. We put less than after the starting value in a range to exclude it. Then we put a less than before the ending value in a range to exclude it. According to example, we have three columns: range, starting value, end value. For the first one, it includes both end value as well as the starting value. For the second example, it excludes the last value that we have defined in the range. And in the third example, it excludes the initial value that we have defined in the range. And in the last example, it excludes both the initial and the final value that we have defined in the range. Low and high keyword. So here we have used proc format value. So in this program, we have used the lowest possible value as low, because if we are not aware what is the lowest value, so we have used the keyword low. And we also do not know what is the highest value that we have. What is the highest value we have for the salary? So here we do not know the range of the highest value for a particular format. So we gave the keyword high. The low keyword includes missing values for character variables, and it does not include missing values for a numeric variable. Applying a numeric format. Proc format value tier, so that is the format, and this is our program. Proc print data equals to Orion period sales, and we have defined the variable names to be displayed, and we have applied this tiers format with the salary variable. Let's go ahead and open the program. Let's go ahead and submit this program. So as soon as we run this program, now for the value 49,999 period 99 has been given the tier 1 group, because we have excluded the value in the format, this one. So any value less than 50,000 would be included in tier 1. Now according to the current situation where we have used high and low, so as we are not aware of the range here, so what is the lowest range and what is the highest range, so we are going to submit this program. So this will also produce the same result, except if it has any missing values, that will be displayed as missing. It will not get any formats applied over it. When we view the report, this is what the report that we have already seen. User defined format examples. So if we talk about this example here, where we are taking different ranges and applying those ranges in a different pattern. Here we are applying a format with the value statement by the name MNTHFMT, that is month format. So 1, 2, 3. If it encounters either of these value, it will label it as quarter 1. If it finds any value between 4 and 6, inclusive 4 and 6, it will give the value quarter 2. And if it finds anything between 7 and 9, it will give the value quarter 3, and so on. And for a missing value, it will give the word missing, and for any other value it will give the word, or it will label it as unknown. So we will run this program and we will see what happens. So multiple user defined formats can be included in a single proc format step, and then multiple user defined formats can be applied in a single proc step. Let's go ahead and see the demonstration. So there are two formats that we have created here. One is character, other is numeric. So any number of formats can be, user defined formats can be created in a proc format step, and in proc print step we can apply any number of user defined formats along with the SAS defined formats. Let's go ahead and submit this program and check if it works. Perfect, it works perfectly fine. So the country format is applied on country variable, the tiers format has been applied to the salary variable, and the month year format was applied to the birth date and hire.